In question 3, the problem statement says in figure 6.18, this figure given here, if LM is parallel to CB, LM is parallel to CB and LN is parallel to CD. So LN is parallel to CD. Then prove that AM by AB, observe this ratio in the figure carefully, AM by AB is equal to AN by AD. So this is what we have to prove, and here's the reasoning we will use to solve this problem. First, we will apply the basic proportionality theorem to triangle ABC since LM is parallel to CB, and we will obtain AM by the whole segment AB equal to AL by the whole segment AC. Then we will apply the basic proportionality theorem to triangle ADC since LN is parallel to CD, and this will give us AN by the whole segment AD also as AL by the whole segment AC. And since both AM by AB and AN by AD are equal to AL by AC, right, as you see in this figure, we will get AM by AB equal to AN by AD. So let's write this solution step by step now properly. So first we observe triangle ABC and we apply the BPT to triangle ABC. So in triangle ABC, LM is parallel to CB. This is basically given to us, and because of this we have AM by AB is equal to AL by AC, and the reason is the basic proportionality theorem, and we can label this equation 1. Now similarly, let's apply the BPT to triangle ADC. So in triangle ADC, LN is parallel to CD, correct? So now if we apply the BPT, we will get AN by AD is equal to AL by AC. Again, the reason is basic proportionality theorem. So now if we compare these two equations that we have obtained, equation 1 and 2, we see that the RHS is the same in both AL by AC and AL by AC, and therefore from 1 and 2 we can say that the LHS, the two left hand sides, will also be equal. So AM by AB, the LHS of equation 1, will be equal to AN by AD, the LHS of equation 2. Okay, and this is what we had to prove. So with this we have completed question number 3.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.